So next I am going to discuss the solutions of the next three questions, 58, 59 and 60 now, one after another. After that I will be showing another 9 questions probably in friction. That is, I will be showing the continuation for the assignment in friction after discussing the solutions of 58 to 60 in this class. Come on, look at the question number 58. A man of mass 50 kg standing on the plank of mass 100 kg kept on a smooth floor is pulling the same plank with the force of 100 Newton. Both the man and the plank move together. The force of friction acting on the man is. So here the man pulls the string horizontally towards left. The given figure, the man pulls the string horizontally towards left. So the man pulls the string horizontally towards left. So the force exerted on the string by the man the man pulls the string horizontally towards left. So the man exerts a force on the string horizontally towards left. The man pulls the string horizontally towards left. So the force exerted on string by the man acts horizontally towards left. According to Newton's third law, to every action there will be always an equal and opposite reaction. Here action is the force exerted on the string by the man, which acts towards left side. So the direction of the reaction will be opposite to the direction of action. If action is towards left side, reaction will be directed towards right side. So reaction will be the force exerted on man by the string. This reaction force on man by the string we call tension. Magnet of this force on man by the string. This is the magnet of tension, the string. So according to Newton's third law, action and reaction forces always have same magnitude. So if capital T represents the modulus or magnitude of the force on string by the man, then the magnitude or modulus of the force exerted on the man by the string is also equal to T. And this magnet of T is given to be 100 newtons. It is given that the man pulls the string with a horizontal force of magnet 100 newtons. So the man experiences a force T towards right side. So the man tends to move towards right side. Therefore, the force of friction on the man by the plank, because the man tends to move towards right side relative to the plank, the frictional force on the man by the plank acts towards left side. From Newton's third law, if force of friction on the man by the plank acts towards left side, then the frictional force on plank by the man will be directed towards right side. Because according to Newton's third law, action and reaction force are equal in magnitude. So if the force of friction on the man by the plank acts towards left side, then the force of friction on plank by the man acts towards right side. The tension force by the string on the plank acts along the string and directed away from the plank. The tension force exerted on the plank where the string acts along the string away from the plank towards right side. So I draw a separate freeboard diagram for the plank and separate freeboard diagram for the man. I am showing the forces in the horizontal direction specifically. I don't mean there are no forces in the vertical direction. Forces are acting even in the vertical direction, some forces like weight, mg and normal force. But there is no motion in the vertical direction, so resultant of forces in the vertical direction is 0. So in the freeboard diagram for the man, you must show the forces acting on the man. The freeboard diagram for the plank, you must show the forces acting on the plank. FBD is a short form for freeboard diagram. So the forces acting on the man must be indicated in the freeboard diagram for man. The force acting on the plank must be shown in the freeboard diagram for plank. So the tension force exerted on the man by the string should be shown in the freeboard diagram for the man. This reaction force on the string by the man should not be indicated in the freeboard diagram for the man. So the frictional force on the man acts towards left side, so it should be shown in the free body diagram for the man. The frictional force on the plank acts towards right side, so it should be shown in the free body diagram for the plank. The tension force on the plank acts towards right side, so it should also be shown in the free body diagram for the plank. There is no question of friction between the plank and the floor is 0. That means the plank is resting on smooth floor, so there is no frictional force by the floor. Of course, in the vertical direction, the weight of the man acts downwards. Let M1 denote the mass of the man, which is given to be equal to 50 kg. There will be normal reaction force on the man by the plank, which acts vertically upwards. This N1 is the magnitude of normal reaction force on the man by the plank, which acts vertically upwards. So the normal force on man by the plank will have same magnitude as the normal force on man by plank. If N1 is the magnitude of normal reaction force on the man by the plank, then magnitude of the normal force on plank by the man is also equal to N1. But the force on plank should be shown in the free body diagram for plank. The force on man should be shown in the free body diagram for man. So the weight M2G of the plank acts downwards. Here M2 is the mass of the plank, which is given to 100 kg. There will be one more normal reaction force on the plank by the floor. Let N2 denote the normal reaction force on the plank by the floor, which acts upwards. Both the man and the plank move in the horizontal direction towards right with the same acceleration. Let small a denote the magnitude of acceleration of the man. Magnitude of acceleration of the plank is also same, directed towards right. So there is no motion in the vertical direction, so net force in the vertical direction is 0. So given that the man and the plank move together horizontally towards right with no relative motion between them, that means the type of friction that exists between the man and the plank is a static friction. Then there is no slipping between them, two masses. So resultant for the man in the horizontal direction towards right is T minus small f. You can also write as Fs, which represent the static friction between the man and the plank. That is equal to, from Newton's second law, product of mass of the man and magnitude of its acceleration. Resultant force of plank towards right is equal to Fs plus T. From Newton's second law, that can write M2A. So adding these two equations, you get 2T equal to M1 plus M2 into A. So magnitude of the acceleration, common acceleration, is equal to 2T by M1 plus M2. So here T is 100 newtons, M1 equal to 50 kg, M2 equal to 100 kg. So M1 plus M2 is 50 plus 100 kg. So you get the magnitude of acceleration from this as 4 by 3 meter per second square. You can substitute this magnitude of acceleration in one of the equations at the top. So from first equation at the top, you can substitute T equal to 100 newtons on the left side minus Fs, M1 equal to 50 kg. Magnitude of acceleration is 4 by 3 meter per second square. From that you get magnitude of friction between the two. You can try to simplify it yourself. Come on, copy down and complete the simplification. You get magnitude of static friction between the two is 100 by 3 Newton. That's the answer. So magnitude of static friction less than the limiting value. So even though I have completed discussion of the question number 58, I want to do some further discussion about this question, even though we have completed solution, because sometimes you may be asked what is the maximum horizontal force with which a man can pull the string so that both the plank and the man move together, or what is the maximum common acceleration with which they can move together so that the man does not slip on the plank. So the static friction between the man and the plank reaches the maximum value at the instant just before the man slips. So he can subtract the first equation from second equation. So I am discussing the calculation to find the maximum common acceleration with which they can move together. And what is the maximum force which can be applied by the man so that they move together. So you can observe that 2 into Fs is equal to M1 minus M2 into A. So you can substitute this value of A in one of the equations. You can substitute the value of A from this in one of the equations. You substitute the value of A, suppose in the first equation. From this equation, from the last equation, you can write A equal to 2Fs by M1 minus M2. You can substitute in the first equation. So magnitude of T tension in the from first equation, Fs plus M1A. A means you can substitute this value of A here on the right side. 2Fs by M1 minus M2. So therefore you get T equal to so 3M1 minus M2 by M1 minus M2 by Fs. So maximum force that can be applied by the man. So that the man and the plank can move together is equal to T maximum is equal to 3M1 minus M2 by M1 minus M2 into Fs maximum. Only I am not discussing the solution of the problem I have given. I have already completed the solution of the problem I have given. I am discussing beyond the solution of the problem. That means sometimes you may be asked what is the maximum force with which a man can pull the string so that they move together. Or what is the maximum acceleration which they can move together. To find maximum acceleration, you have to consider Fs maximum. Fs maximum between the two equal to coefficient of friction between the man and the plank into N1. N1 equal to M1G. You should just know the procedural part. You need not have to calculate the numerical values now. So from if you substitute this value of Fs maximum on the right side of this equation, you can find a maximum horizontal pull which a man can pull the string, so that the plank and the man can move together. And to find the maximum acceleration which with the man and the plank can move together, you can take Fs maximum value of Fs here equal to mu m1 in this equation. In case you want to copy this part of the calculation, also you can take a pause and copy this part of calculation. So next I am going to discuss our question number 59. So for question number 58, which I discussed earlier, second option is answer 100 by 3 Newton towards left. Second option is answer. So see the question number 59. This problem also comes under one of the special cases I have discussed in the past. You please refer to the special cases in the beginning of friction I have discussed. The first set of special cases I have discussed for motion on the rough horizontal floor. I have discussed how to calculate the minimum pulling force required to start the block moving. See the question number 59. A pulling force equal to the minimum force required to just start the block moving is applied on the block which is initially at rest on the rough horizontal floor. The same force is maintained even after the motion begins. And find the acceleration of the block. So as I discussed earlier, in one of the special cases, in the motion on the rough horizontal floor, the least value of the pulling force required to just start the block moving, if it is initially at rest on the rough floor, is given by nu s mg by cos theta plus nu s into sin theta, which I have discussed in the past, which you can also write in terms of the angular friction. Mg sin phi by cos of theta minus phi. As discussed in the past, the pulling force required to just start the block moving will be minimum when cos theta minus phi is maximum. That is when cos theta minus phi equal to 1 or theta minus phi is 0 or theta equal to phi. That means the pulling force required to just start the block moving will be minimum when the pulling force is applied at an angle equal to the angle of friction between the two surfaces. Here phi is the angle of friction between the block and the floor. Theta is the angle which the pulling force makes with the horizontal. Let F denote the magnitude of pulling force. So the minimum value of the pulling force required to just start the block moving is equal to mg sin phi by cos theta minus phi. Cos theta minus phi is 1. So here you can construct to find the value of sin phi, I can construct a right angle triangle with one angle equal to theta or phi. Both are equal here. So tan phi is equal to nu s. Phi is the angle of friction between the two surfaces in contact. As I discussed, tan phi equal to nu s by 1. So I can construct right angle triangle with one angle equal to phi or theta. Length of side opposite angle phi equal to nu s. Length of side adjacent to the angle phi equal to 1. So that tan phi equal to opposite side by adjacent side. That is nu s by 1. So from Pythagoras there is root of 1 plus nu s square. So sin phi, when theta equal to phi, sin phi can be written as equal to opposite side by hypotenuse side, nu s by under root of 1 plus nu s square. So the pulling force applied on the block in the given problem has magnitude F equal to nu s into mg by root of 1 plus nu s square. So given that same force is maintained even after the motion begins. It is given the same magnetic pulling force is maintained even after the motion begins, but after the motion begins, the frictional force acting on the block becomes kinetic friction. You can copy the working here. The problem is not completed with this step. You have to find the acceleration of the block here. For that, you have to find magnet of kinetic friction of the block. To find the magnet of kinetic friction of the block, you must know the magnet of normal reaction of the block. Here, kept left represent the magnet of pulling force applied on the block by an external agent, which acts at an angle theta to the horizon. The other force which acts on the block are its weight mg acts vertically downwards. The weight mg of the block acts vertically downwards. The normal reaction force on the block by the surface of floor acts vertically upwards, perpendicular surface of floor and direct away from surface of floor. The force of kinetic friction during the motion. I am showing the free body diagram for the block during the motion while it is moving. Acts opposite to the direction of the motion of the block relative to the floor. We can resolve this pulling force into rectangular components along the horizontal and vertical directions. You can choose the horizontal direction, which is the direction of the motion of the block as x-axis. In vertical upward direction as y-axis. So you can resolve the pulling force into rectangular components. The horizontal component of pulling force will have magnitude F cos theta which acts in the direction of motion. The vertical component of pulling force will have magnitude F sin theta which acts vertical upwards. Come on, all of you first finish copying the working up to this step. All of you please finish writing or copying the working part up to this step so that I can continue the working after finish copying. In case you need more time to copy the solution of the problem, you can take a pause and take your own time. First, you must finish copying the working part so that I can do the calculation for continuation for this part. I think you have finished copying the working of the earlier steps. So to find magnet of normal reaction, we find Fy. Fy represents the y component resultant force. Let n denote the magnet of normal reaction on the block by surface of floor which acts vertically upwards along positive direction of y-axis. The vertical component of pulling force with magnitude F sin theta also acts vertically upwards in the positive direction of y-axis. The weight mg of the block acts vertically downwards in the negative direction of y-axis. So y component of resultant force of the block is equal to n plus F sin theta minus mg. But the block has no motion in the vertical direction, so y component of resultant force of the block is 0. So magnet of normal reaction of the block is equal to mg minus F sin theta. Here sin theta equal to sin phi. So we have already calculated the value of F in the previous step. We have already calculated value of F here. F equal to mg sin phi. Theta is also equal to phi. Phi is the angle of friction. So magnet of normal reaction, the block will be mg into 1 minus sin square phi or mg into cos square phi. So magnet kinetic friction of the block during the motion is equal to nu k into m. That is nu k. Definitely this problem is a bit lengthy problem compared to the other problems I have done. This way I am doing only keeping in a all India entrance examinations. I have constructed right angle triangle. Before you can look at the same triangle, tan phi is nu s by 1. So cos pi from this we can write 1 by root of, in the right angle triangle, cos pi equal length of adjacent to phi divided by length of hypotenuse. 1 by root of 1 plus nu s square. That's the value of cos pi. So magnitude of kinetic friction of the block during the motion is equal to nu k to mg by 1 plus nu s square. You look at the free body diagram which I have copied earlier. Step. The block has no motion parallel to the axis. Here y component resultant force is 0. Therefore resultant force of the block can be written as equal to Fx. Means resultant of forces acting along x-axis. The horizontal component of pulling force with magnitude F cos theta acts along positive direction of x-axis. Towards right. Fk represents magnitude of kinetic friction which acts toward left side. The negative direction of x-axis. From Newton's second law, now here Fx you can write F cos theta minus Fk. From Newton's second law, this can be equated to m into a. You can substitute the values of F and Fk here, and cos theta you can same as cos phi because theta equal to phi here. Come on, copy down the working. You substitute here. Put F equal to mg sin phi, that is equal to mg into nu s by root of 1 plus nu s square. And cos theta is same as cos phi, which is equal to 1 by root of 1 plus nu s square. Come on, substitute this value of Fk on the right side. Come on, all of you copy down now. Please take a pause and copy down the solution of the problem. You can try to complete the simplification part yourself. You copy down the solution of the problem up to this step and try to please finish the calculation part. First you find magnitude of acceleration in letter notation in terms of nu s, nu k and g, and final step you substitute the given values. Come on, copy down. Come on, I have shown the continuation part of the simplification which you are supposed to have done. So I have written earlier Fx equal F cos theta minus Fk equal MBA. So I have substituted here F equal to nu s mg by under root of 1 plus nu s square, and cos theta equal to 1 by root of 1 plus nu s square, and Fk equal nu k into mg by 1 plus nu s square. That is equal to MBA. Simplifying this, you are supposed to get magnitude of acceleration as nu s minus nu k into g by 1 plus nu s square. Nu s is given to be 3 by 4 or 0.75, nu k is 0.65, g take it as 10 meter per second square. Simplify this, you are supposed to get the answer as 0.64 meter per second square. If you want to copy the simplification part, please copy down the simplification part. Take a pause and complete the copying the solution. Next, I want to discuss the next question. So for question number 59, which I have just discussed now, first option is answered, that is 0.64 meter per second square. Next, I will see the question number 60 here, which was given in one of the previous entrance examination, 2001 JIPMER entrance. See the question number 60. In the figure shown, block of weight 10 Newton is resting on a horizontal surface. The coefficient of static friction between the block and surface is nu s equal to 0.4. Force of 3.5 Newton will keep the block in uniform motion once it has been set in motion. A horizontal force of 3 Newton is applied to the block when it is initially at rest. Then 4 options are given. As you know, if the block is initially at rest, the block starts moving only when the magnitude of the horizontal force applied on the block is equal to the maximum value of force of static friction or limiting friction. So the maximum value of the force of static friction or limiting friction is equal to nu s into n, where n is the magnitude of normal reaction. Here the weight mg of the block has magnitude equal to 10 newtons. N is represents magnitude of normal reaction on the block by surface, by the horizontal surface on which it rests. It acts vertically upwards. Kept left with the horizontal force applied on the block. The force of friction on the block by surface in contact acts towards left side. The block starts moving only when the magnitude of the horizontal force applied on the block is more than the limiting friction. Magnitude of limiting friction E is into N because the block has no motion in the vertical direction. Here N equal to mg in magnitude. E is 0.4. mg equal 10 newtons. So maximum value of force of static friction between the two surfaces in contact or limiting force of friction between the two surfaces in contact is 4 newton. That means the block starts moving only when the horizontal force applied on the block is greater than or at least equal to 4 newtons. But once it has been set into motion, the horizontal force needed to maintain the motion of the block is equal to magnitude of kinetic friction. Here we are given that a force of 3.5 newton will keep the block in uniform motion. That means magnitude of force of kinetic friction can be taken as nu k into mg, that is equal to 3.5 newton. That means mg is 10 newtons. So from that you get the value of nu k as 0.35. But that you are not asked to find that. You are asked to find the magnitude of frictional force on the block when a horizontal force of 3 newton is applied on the block when it is initially at rest. The block is initially at rest. The block starts moving only when the magnitude of the horizontal force applied on the block exceeds limiting friction. Here magnitude of limiting friction is 4 newton. That means the block starts moving when the horizontal force applied on the block exceeds 4 newton. It means when a horizontal force of magnitude 3 newton is applied, when it is initially at rest, the block will be at rest. The block does not move. And magnitude of static friction on the block will be, when it is at rest, resultant force of the block is 0. So resultant force of the block in the horizontal direction, let us choose the horizontal direction as x-axis. Or x direction is equal to horizontal force applied, magnitude of horizontal force applied minus magnitude of static friction. That is 0. That means the magnitude of static friction in this case same as the magnitude of horizontal force applied, that is 3 newton. So therefore fourth option is answer for this question. So with this I have completed discussion of all the questions 1 to 60 in the assignment in friction. So I would like to show you another 9 questions in this assignment for friction. That means I will be showing another 9 questions, the solutions of which I will be discussing in my next class. So in continuation to this, I am going to show you the continuation for assignment in friction. That means I am going to show you the questions numbering from 61 to 69. So next I am going to show you the questions in continuation to the earlier assignment in friction. That is already have shown you questions 1 to 60 and discuss the solutions of all the questions from 1 to 60. I am going to show you the questions numbering from 61 onwards. I will be showing the questions numbering from 61 to 69. In my next class I will be discussing the solutions of these questions. See the question number 61. Two blocks A and B of masses MA and MB respectively are connected with a string passing over a frictionless pulley fixed at the corner of a table. The coefficient of friction of A with the table is nu. What is the minimum mass MC of third block C? That may be placed on A to prevent it from moving. Mass of A is given to be 10 kg, mass of B 5 kg, nu between A and table is 0.2. Come on, start trying the problem. You are given the options on the screen. You can take a pause and take your own time to try the problem. You can take a pause and take your own time to try the problem. You can even copy the figure and finish trying the problem yourself. I am going to show you the next question on the screen. See the question number 62. The body of mass limb is kept on a rough horizontal surface. Person is trying to pull the body by applying a horizontal force, but the body is not moving. The force exerted by the surface on the body is kept left, where we are given 4 options. Kept left equal to mg, second option f equal to umg, third option mg less than or equal to f less than or equal to mg root of 1 plus nu f square, fourth option mg greater than or equal to f greater than or equal to mg root of 1 plus nu square. Come on, copy down this. Come on, try to solve the question. Need not copy the question. This question was given one of the previous entrance examination, MPPET. In case you need more time to answer the question, take a pause and take your own time. I'm going to show you the next question on the screen. See the question number 63. A block of mass volume lying on a rough horizontal plane is acted on by a horizontal force P and another force of magnitude Q inclined at an angle theta to the vertical. The block will remain in equilibrium if the coefficient of friction between the block and the surface is. You are given 4 options on the screen. Come on. Copy the diagram and try this question yourself. Come on, take a pause and take your own time to try the question. You can take a pause and take your own time to try the question. I am going to show you the next question on the screen. This was also given one of the previous entrance examinations. See the question number 64. Block of mass 10 kg is placed on a rough horizontal surface having coefficient of friction nu equal to 0.5. The horizontal force of 100 Newton is applied on it. The accelerator of the block will be. You are given 4 options. You have to find out the answer. You take G as 10 meter per second square, even though it's not mentioned here. Better you write G equal to 10 meter per second square for this problem. Come on, try this question. So in case you need more time to answer the question, take a pause and take your own time. I'm going to show you the next question on the screen. See the question number 65. Block of mass 1 kg is placed on the horizontal surface of a truck moving with an accelerator of 5 meter per second square. The coefficient of friction between the surface of the truck and the block is 0.6. The frictional force of the block is, 4 options are given. You take G as 9.8 meter per second square for this question. G equal 9.8 meter per second square. Come on, try the question. You can take a pause and take your own time to try the question. I'm going to show you the next question on screen. See the question number 66. Block B of mass 5 kg is placed on another block A of mass 10 kg, which rests on a smooth horizontal surface. If nu equal to 0.2 between A and B, the force of 40 Newton is applied on A. The accelerator of A is. Come and try the question. Here also take G as 10 meter per second square. So you may require more time to answer the question. Take a pause and take your own time. I'm going to show the next question on screen. See the question number 67. Block of mass 4 kg is placed on a rough horizontal plane. A time-dependent horizontal force F equal to small k into t acts on the block within brackets k equal to 2 Newton per second. That means k is a constant here. Of course, understood that small t is time in seconds. The frictional force between the block and the plane at t equal to 2 seconds, at t equal to 5 seconds will be. You are given that the question of friction between the block and table to 0.2. Come on, try to answer this question. Take G as 10 meter per second square. Please take G as 10 meter per second square for this question. Come on, try the question. You may need more time to answer the question. Take a pause. Take your own time to try the problem. I'm going to show the next question on screen. See the question number 68. The ladder weighing 250 Newton is placed against a smooth vertical wall, having coefficient of friction between it and the floor as 0.3. Then what is the maximum force of friction available at the point of contact between the ladder and the floor? Come on, try this question. So you may require more time to answer the question. In case you require more time to answer the question, take a pause and take your own time. See the last question, question number 69. In the figure M1 equal to M2 equal to 2 kg and coefficient of friction between M1 and table is 0.5. The mass of string and pulley are negligible. Pulley is frictionless. The mass are released from rest. The magnitude of accelerator the mass is. So take G as 10 meter per second square. Come on, try the question. Come on, you take a pause and take your own time to try the problem. You can take a pause and take your own time to try the problem. Next, I am going to show you the answers for questions numbering from 61 to 69 now, so that you can check up your calculations and working. You can check up your answers. See the answers for question number 61. Second option is answer. For question number 62, third option is answer. For question number 63, first option is answer. For question number 64, third option is answer. For next two questions, 65 and 66, first option is answer. For question number 67, second option is answer. For question number 68, first option is answer. For question number 69, second option is answer. Come on, check up your answers. So in my next class, I will be discussing the solutions of the questions numbering from 61 onwards up to 69.